All right, today what we're going to do is we are going to go over basically the concepts that you were taught in your last video on moles and converting to mass or converting to molecules. And one of the ways that I like to teach this is using something called mole islands. So let's take a look at our first island. So here's Mole Island. This is where we're just talking about things in the mole. I know, I'm a really good drawer, aren't I? Okay, so we have Mole Island where your answer is in moles. We have the Gram Island or Mass Island. That's when you're just talking about everything in grams. And then we also have one more island. It's called the Representative Island. This is when you're talking about, you know, how many representative particles there are. Are you talking about, you know, you have this many atoms or this many molecules? And the one thing I want you guys to remember is that in order to go from one island to the next, you're gonna have to cross a bridge. Okay, so we have a bridge that goes from mass to the mole island, and you have a bridge that goes from the mole island to the representative particle island. And so in order to get from one island to the next, you have to go over a bridge. And so you're going to have to do a conversion. So for instance, if you're going to go from mass island to the mole island, you're going to have to calculate the molar mass. So this is where you take your compound or your element and you figure out the grams, just looking at the periodic table, and that's how many grams are in 1 mole of that compound. So you're going to use molar mass to convert over to moles. And then if we want to go from the mole island to the representative island, you're going to have to use Avogadro's number. So remember, anytime you have 1 mole of something, there are 6.02 times 10 to the 23rd representative particles. So this could be, if you have a mole of atoms, then you have 6.02 times 10 to the 23rd. If you have a mole of molecules, it's 6.02 times 10 to the 23rd. So you have to use your little bridges in order to go from one island to the next. And you can't swim around. You can't go from Mass Island directly to the representative island. You can't skip the mole island. Otherwise, the little sea serpent is going to come and eat you. So it doesn't work that way. You have to go from one island to the next, and you can only use bridges. Okay, so let's put this into practice. Okay, so it's in your best interest to get out a piece of paper and write this down as we are going through these examples. And I've kind of put up a similar island diagram up in that top right corner of your screen. So you can see we have the grams island, the mole island, and the representative particle island. Okay, so this is the order that you have to go in. So for instance, say that we want to know how many moles are in 25 grams of water. So just like on Monday, you're going to start with what you know. They tell us that we have 25 grams of water. But if you look up there at that little island picture, you can see that if we're in grams and we need to go to moles, we have to calculate the molar mass in order to get over to moles. So in order to do our railroad tracks, you're gonna have to find the molar mass. Anytime you go from grams to moles, figure that out. So we look at our periodic table. We know that hydrogen is 1 and oxygen is 16, but we have 2 hydrogens and 1 oxygen. So H2O weighs 18 grams per mole. Now that we have the molar mass, we can use that to convert to moles. So we started with grams. We're going to have to put grams on the bottom to make sure it cancels out. And you have 1 mole of water is 18 grams. So our grams cancel out. We're left in moles. And that's all we need to do. We started with 2 sig figs. We're going to round to 2 sig figs. So we should have about 1.4 moles of water if we have 25 grams of water. Okay, so that's how we're going to use our little island diagram. And if it helps you, write out that little island diagram right there. It's just some squares. You can do that. All right, let's do another one with scientific notation, because I think sometimes these ones are more difficult. It says how many moles are in 3.4 times 10 to the 23rd molecules of H2SO4? Again, go ahead and just start with what they give you. Okay, we know we're at 3.4 times 10 to the 23rd molecules. We're talking about the number of particles. We have this many molecules. So if we look up at our little island diagram, we can see that we are in the number of particles island. We're in the representative particles island. So it doesn't want us to be in molecules, it wants us to be in moles. So notice that to get over to moles, we're going to use Avogadro's number. Okay, so there are 6.02 times 10 to the 23rd molecules in 1 mole. That's how we're going to get over to mole island. Our molecules cancel out. And remember, in your calculator, you're going to go 3.4 EE23 divided by 6.02 EE23. And we started with 2 sig figs, so we're going to try and round to 2 sig figs. So we have about 0.56 moles of H2SO4. So hopefully this is kind of making sense, and that little island diagram is helping you out just a little bit. But what if we're going to go, we want to know grams, but we're in molecules. So again, let's start with what we know. It says we have 8.2 times 10 to the 22 molecules. So look up at our little island conversion chart, and you can see we're on the number of particles island. But we have to get all the way over to grams. You can't just go to grams. You have to go to mole island first, and then you can go over to gram island. Remember, you don't want the sea serpent to come and eat you up. So first of all, we're in molecules. We have to get to moles. So if we look right there, we can see in order to get to moles, we're going to use Avogadro's number. 6.02 times 10 to the 23rd molecules are always in 1 mole. Okay, so we're out of molecules. We're in moles right now, but we still have to go over to gram island. So we have to cross that bridge. And in order to do that, we have to get the molar mass. And we're dealing with N2I6. So we got to go from moles to grams. We're going to figure out the molar mass. Iodine, if we look on the periodic table, is 127. I just am rounding. Nitrogen is about 14. 2 nitrogens and 6 iodines. So we should have about 790 grams per mole. So now that we have the molar mass, we can go ahead and do the conversion. So if we have 1 mole of N2I6, it's going to weigh 790 grams. So right then and there, we can cancel out our moles. We're in grams, and we're done. So remember, everything on top is times, everything on the bottom is divided. Use that EE function on your calculator. It's in your best interest to try and put these into your calculator and see if you can get the same answer as me. Because make sure that you know how to use that EE function. And so if we put that in, you should get something about 107.6 grams of N2I6. I know I didn't do correct sig figs. This is one where it was difficult for me to try and figure out how to do 2 sig figs. So it's okay if you can't do sig figs, but you get the right answer, you're going to be okay. I'm going to give you a worksheet with just 3 problems on it. I would love it if you would work it out, take a picture of it, and either text it to me or email it to me, or I have had students that have uploaded pictures into Google Classroom. It's up to you, but I want to see you put out your railroad tracks and work out these 3 questions that I've assigned to you on an attached document. So I hope you guys have a great day. Don't worry about this. We'll work on this some more next week. And I can't wait to see you guys soon. All right, have a good one.